Welcome and good morning, students. In this video we are studying topic number 5, acid, bases and salts from science 1. This topic include Arrenhius theory of acid and bases, concentration of an acid or base, pH of a solution, pH of an acid and base, and salts. In our day-to-day life, we are using various substances having a bitter taste, sour taste, sweet taste, salt taste, right? Different tasted substances are we use in our day-to-day life. Among them, some can be called as a acid, some can call as a base, and some can call as a salt. How it can be divided in this topic we are going to study. Some compounds are we are using in day-to-day life, but they are made of combinations of two ions. We are using these substances. Among those, some substances are called as a ionic compound. What is meant by ionic compound? See, what is meaning by ionic compound? In ionic compounds, there are two components. One is cations and second is anions. Cations is positive charge ion or radical. Anion is negative charge radical. Okay. How they are produced? They having the opposite charge. Generally, cations are produced from the metal. Suppose there is a sodium metal. In sodium, electron configuration 281. That means in sodium atom there are 2 electrons in a first orbit, 8 electrons in a second orbit, and how many remaining? 1 is outer cells. Okay. Metals have ability to give electrons while they complete octet. So sodium last orbit contain only 1, so it gives this electron, and when it gives this electron, its outer orbit is disappear and the second orbit become the last orbit, which contain 8 number of electrons. So what happens in the sodium? The protons are 11, but the electrons are become 10. So positive charge, protons, one proton is more. That's why, and the one proton carry the positive charge. That's why the sodium atom become positive charge. It become positive charge. Similarly, in a chlorine is a non-metal which contains 287 electronic configuration 287. In chlorine, first orbit 2 electrons are there, second orbit 8 electrons are there, and the third orbit contains the 7 electrons. Okay. And the chlorine is a non-metal, and when the non-metals have ability to accept the electron, in the last orbit 7 electrons are there. If we take 1 electron, its octet is completed. So what happened? Because of accepting 1 electron, now in chlorine the protons are 17, but the electrons are become 2 plus 8 10, 10 plus 8 become 18. So on chlorine one electron is more, and this one more electrons means this atom of chlorine become negative charge, right? It become positive because its electron count become 2 8, and it become negative because electron count become 2 8 8. Okay, so this is become this ion is called the cation, and this ion is called as the anion, both having the opposite charge. So due to this opposite charge, these both are attracted with each other, because opposite charge particles are attract with each other, and they combine together. They combine together to form one molecule of a new substance. This new molecule of substance means it contains Na and Cl, that is sodium chloride. These two molecules of sodium and chlorine are bound because of opposite charge of force. This force is called as a ionic bond. This is called as a, because two ions are attached with each other, so that bond, that force called ionic bond, and that's why the sodium chloride is called as a ionic compound. Okay, these ionic compounds are very high stability. It found the very high stability. Okay, in this way, the compounds of ionic compounds of these ionic compounds can be dissociated. These ions can be dissociated if we dissolve in water. So see, dissociation of ions of ionic compound. Why? How they are dissociated? Generally, they are having the two ions in the solid state. These two ions are compactly arranged, but when it dissolve in a water, so the water molecules are enter in between these two ions of molecules. So these molecules in a solution which are compactly arranged, because of presence of water, these molecules are get abroad from each other because of the water energy. This is known as a dissociation of a ionic compound, and then this this ionic compound with the water form the solution that is called as a aqueous solution, and it is generated by letter AQ. Aqueous solution called the aqueous solution. Arrhenius in 1887, Arrhenius put the theory of acid and base. He explained how we can define the acid and base. According to Arrhenius, we can say which is the acid when dissolving water, when substance dissolving in water gives hydrogen ions. What is give? If it gives the hydrogen ions, then that substance is called as a acid. Means if we HCl, it dissociate in water, it dissolve in water, then it forms the hydrogen ion and the chlorine ion. So hydrogen and the chlorine ion form. So here hydrogen ion, that's why it's called as a acid. Similarly, in a H2SO4 also, if dissociate in water, it form hydrogen ions and the HSO4 ions. Okay. Then HSO4 ion again dissociated to form second hydrogen ions and the sulfate ions. Okay, that's why these substances, acid or H2SO4, can be called as ions because they form the hydrogen ion when dissociated in water. Similarly, they are also say that base. So when dissolving in water, base means dissolving in water gives OH ions, not iron. Suppose NaOH is dissolved in water, it forms sodium ion and the hydroxyl ions, as well as calcium hydroxide. When dissociated in water, it also forms calcium 2 ions and the 2OH hydroxyl ion. That's why NaOH and the CaOH2 are known as a base because on dissolving water it gives the OH ions. Their acid or bases can be called as a strong or weak. So see, classification of acids and base. Acids and bases. While we classify acid and bases, classify into as a strong and weak. Okay, there is a strong acid and the weak acid. Strong acid and weak acid. Which is called a strong acid when it dissolving water, dissolving in water, completely dissociate. Dissolving water, dissociate completely. That is the most important. Dissociate completely. That acids are called as a strong acids. HCl, H2SO4, HNO3, HBr are in water dissociate means they form the both ions separately. That's why there was a strong acid. The weak acid dissociate dissolve in water. Water does not dissociate completely. Okay, so that's why they are called as a weak acid. H2CO3, CH3COOH, that is the acidic acid, can be called as a weak acid because they completely does not dissociate in a water. Okay, similarly bases can be called as a strong base. Again, dissolving base, strong base. Which are the strong base? Which almost completely dissociate in dissolving water, dissociate completely. That is called as a strong base. That is called as a strong base. NaOH, KOH, CaOH twice, Na2O are the strong bases Okay, similarly bases can be also called as a weak base, which does not dissociate completely in a water when it dissolves. That are like NH4, sodium, ammonium hydroxide, like acids are called as a weak base. And the fifth one is that alkali. In alkali, which are called alkali, there are some bases are highly soluble in water, easily soluble in water. That bases are called as alkali. Which dissociate completely in water? NaOH base, KOH, H NH3 NH3 K are completely or easily or highly dissolved in water or soluble in water, so they are called as a alkali. Among them, NaOH and KOH are the strong alkali. They are strong alkali. Again, there are two types of alkali. They are strong alkali, and NH3 is a weak alkali. Okay, in this way we can decide which how the which type of the acid bases can be classified as a strong acid, weak acid, strong base, weak base, and the alkali. Then on the basis of basicity and acidity, we can also classify the acid and base. See, basicity of acid. What is the basicity of acids? The number of hydrogen, suppose the number of hydrogen ions obtained by dissociation of one molecule, just one molecule of acid or acid is dissolved, so from them hydrogen ions is formed. This is known as such acid is known as a basicity. That acid is called as a basicity. That was the basicity. And the acidity of bases means the number of the number of OH, the number of OH ions obtained by dissociation of one molecule, that is called as an acidity of a basis, or it was the acidity. Okay, so there's a just both as basicity of acid and acidity of basis are both different are same. Only difference is that in a basicity of acid, here hydrogen ions form. In the acidity of basis, hydroxyl ions are formed. Okay, so those are the different types of the acid and bases can be used in our day-to-day life. Okay, next period we will see the concentration of acid and bases, the pH of solutions, and the universal indicator. Thank you so much.